Hello, welcome to Benchmark. Today we're going to talk about the Benchmark HPA4 headphone amplifier and the LA4 preamplifier. The two products are basically the same, except that the HPA4 has the THX888 headphone amplifier, which is the top-of-the-line THX headphone amplifier featuring feed-forward error correction. One of the unique things about it is that the volume control is completely controlled by relays. In fact, everything in the HPA4 is controlled by relays. It's switched by relays. So the input selection, you'll hear a click as we switch inputs. And if I turn the volume down by 20 dB, you'll hear it actually go through 40 steps of precise half dB increments and back up. Now you hear that clicking, and that clicking is music to my ears because those are high precision gold contact relays that were originally made for the telecommunications industry. If you remember, in the old days, you had pulse dialing, and that was normally at 10 pulses per second, but many devices actually supported 20 pulses per second, and these relays were designed to pulse at 20 pulses per second all day long, 24/7, and be very reliable doing that. We're using them to switch the audio to control the volume with a stepped relay-controlled attenuator. And what you hear there, that sound is actually going through 40 half dB steps in 1 second. Now, if we had music playing through the speakers, there would be no clicks whatsoever in the audio. The only clicks are actually coming from the physical relays themselves. Okay, the first thing I'd like to do is just highlight some of the controls that are available through the color display. First of all, I'd like to talk about the optical encoder that controls the volume, and it also has a push function that allows me to control just the headphone output or just the line output, or both of them together. The other thing that we have here is individual mute controls for the headphone or line outputs. And you'll notice that when I release the mute, it does a soft unmute, fading the music back up after I come out of mute. The same is true when I hit the minus 20 dB dim. If I release it, we fade up 20 dB. When I press it, we fade down 20 dB. So that makes it very nice to go between a low-level background music and normal listening. And then there's a balance control that is individually adjustable for the headphones or for the line output. And the other thing we have on the front is a 4-pin XLR connector and a 1/4-inch tip ring sleeve. Both of these are for the headphones. You can use either one. We recommend the 4-pin XLR because it gives you the best electrical connection. Now what we're going to do is we're going to take a deep dive inside the HPA4. I'm going to disassemble the entire unit and show you exactly what's inside. So first we have a heavy gauge aluminum cover. And now inside we've got power supply. We've got the headphone board up in the front. And these are the attenuator boards here in the back. So first thing I'm going to do is I'm going to take the headphone board out. So this is the THX888 headphone board in the HPA4. It's a discrete design, and it's exclusive to Benchmark media systems. So this is a design that we did with THX, and it was the first headphone amplifier featuring the THX AAA technology. We licensed this from THX, and like the circuit that's in the AHB2, this uses feed-forward error correction to keep the distortion 30 to 40 dB lower than it would be in a conventional amplifier. So as you load the HPA4 heavily with some hard-to-drive headphones or some very inefficient headphones, the amplifier stays clean, and that's because of the feed-forward error correction. There's also two relays in here which are part of the protection system that it automatically shuts the amplifier down if you short the output out or overload it or drive it into clipping. Set that aside. So here in the back we have the power entry module. There's two fuses and an IEC input connector that allows you to connect any of a variety of international power cords. So right here we have a AC to 12 volt power supply. It supplies 12 volts DC to the unit. We derive all of our voltages off that 12 volt DC. One of the things that this does, it gives you excellent isolation from the AC line because everything on the audio boards is derived from this 12 volt DC signal. Okay. Up here at the top we have analog attenuators. There's 8 relays for the right channel and 8 relays for the left channel. This is a 256 step attenuator. One of the relays does a half dB step, and another one does a 1 dB step, a 2 dB step, a 4 dB step, an 8 dB step, a 16 dB step, a 32 dB step, and a 64 dB step. And using combinations of these, we can give you any attenuation between 0 dB and minus 127.5. We also have another relay that kicks in for a full mute. There's 4 more relays here which are used to boost the gain. So if we need to turn the signal up, the first thing we do is go through this variable gain input stage. So the balanced input amplifier can operate at unity gain or at 1 dB gain, 2 dB gain, 3 dB gain, all the way up to 15 dB. So we can boost the signal if we need to boost it, and we always do that boost right at the beginning of the signal chain. The idea is to have the highest possible signal level going through the attenuator. The other thing I'll point out about these attenuators and also the gain stage is that this is a fully balanced design. So there's a set of resistors down this side of the relays and a set of resistors down this side of the relays. One side of the relay is for the plus signal and the other side of the relay is for the minus signal. So that's a balanced signal going down both sides of these relays. Now, in order to get the precision that we need to maintain a 0.1 dB accuracy on the volume control over 128 dB range, we have to have very high precision resistors. So some of them are 0.1% and some of them are 1%. And so there's a lot of mathematics that went into calculating which of these had to be extremely precise resistors and in order to maintain the plus or minus 0.1 dB accuracy over the entire volume range. You'll notice that there's 2 identical sides to the board. One is for the left channel, one is for the right channel, and there's actually a split, a complete split between the two. So basically, this is very much a dual mono construction on these two boards to give you good channel separation and prevent any kind of crosstalk between channels. So you'll notice there's two attenuator boards. There's one above the other. This top board is for the headphone amplifier. If this was just an LA4, this top board wouldn't be here. But we have completely separate attenuator for the headphone out and for the line out. And what that allows us to do is to use both of those outputs simultaneously and independently. So I can have different volume on the headphones and on the line output. So that's kind of a really neat feature, is that you can use both at once, or you can quickly go between one and the other to enjoy headphones or line output. So there's the attenuator board. One thing I'll point out is if you look at the back of this board, it's entirely ground plane. And if you look at the top of the board, it's hard to see, but it's almost entirely ground plane. This, like most benchmark circuit boards, is a 6-layer board. And here we have the second identical attenuator board. This attenuator board, of course, is for the line amplifier. Okay. Now what we have here are the plus and minus 18 volt supplies. So 12 volts comes in on this connector, 12 volts DC, and these are DC to DC converters that give us the plus 18, the minus 18. We've got plus 5, plus 3.3, plus 1.8, and plus 1.2. Each of these voltages are needed for various parts of the circuit. This is the FPGA that controls the switching of all of the relays. One of the important things is that we're able to precisely control the timing of the opening and closing of the relays, and this is what gives us the ability to do a soft fade with relays. Virtually every other relay controlled attenuator is going to put some kind of click in the audio because of the imprecise timing of the relay opening and closure. But because we're controlling the relays with an FPGA instead of microprocessor, we have very precise control over when the relays close and when the relays open. And so we do a make before break relay timing so that we don't get any clicks or pops in the audio as we're turning the volume up and down. So that's a unique thing about the benchmark HPA4 and LA4 is this FPGA control. Okay, you can see on the bottom board we've got more relays. These relays are for input selection and for output muting, and there's another bank of them on this input board. So in combination, these are doing all of the input selection, input muting, and when necessary, the unbalanced to balanced conversion. So that's all controlled by the relays. One of the cool things is that when the unit's turned off or when an input is muted, it's physically disconnected from the external cable. And this prevents any risk of damage when the unit's turned off. If you're feeding a signal in and the unit's turned off, it's actually going nowhere because the relays are turned off, and that protects the input from backfeeding while the power is turned off. Same goes for the outputs. The outputs are disconnected when the unit's turned off. So now we're going to take a look at the rear panel. Okay, we have two sets of balanced inputs. We have two sets of unbalanced inputs. We have one set of unbalanced outputs. We have a left balanced out, right balanced out, and a mono balanced out. And these are the trigger I/O ports. These are bidirectional 12-volt triggers. They're compatible with single direction 12-volt triggers that are found on a lot of other manufacturers' products. But the unique thing about the benchmark triggers is they can be hooked up to an output or an input, or they can be used in a bidirectional mode in an all benchmark system. So they auto sense direction, and in an all benchmark system you can turn on the system from any unit in the system, and you can use any unit in the system to turn the entire system off. So it's a lot more flexible than having a trigger input and a trigger output. I can go right off of this to two AHB2s, or one of these could go to a DAC3 and the other one could go to the AHB2s, and then the AHB2s can daisy chain if you've got more than one power amplifier. There's a fuse drawer right here, has two fuses. AC power module is auto ranging from 100 volts to 240 volts, 50 hertz or 60 hertz. So you can just plug this thing in anywhere in the world and not worry about changing input voltage settings. It's just a universal power supply, which makes that very easy. So thanks for watching. That's all of the components that are in the HPA4. The LA4 is identical, except that it doesn't have the headphone amplifier. If you go to our website, there's a lot more information about these products, and we'll have another teardown very soon, where we're going to be tearing down the benchmark DAC3 converters.